So, welcome all of you to our topic of discussion for the OS project, operating system project. And our team have assigned three topics for this project. Now, the topics are write a C program to display resource allocation graph with single instance for deadlock detection. Write a C program. Second topic is write a C program for resource allocation graph to detect deadlock in a system. And third topic is write a C program, avoid deadlock using safety algorithm, single instance, assume there are four processes and 16 resources types. So one by one, we to see every topic and their solution with the code. So our first topic is write a C program to display resource allocation graph with single instance for deadlock detection. So now we are going to discuss about what approach and what intuition that we are applying for this code. So creating a complete resource allocation graph, single instance for deadlock detection in C is a complex task and would require a significant amount of. However, I we can provide simplified things and assume that there are two types of resources and we will create a single instance resource allocation graph. So let's jump to the code. So here is our code and it is written as C language. So one by one, I'm going to discuss this. So start with brief introduction about the topic deadlock detection of computer systems. So it is a C program for the deadlock detection demonstrates a simplified resource allocation graph. Checks if a resource request can be granted without causing a deadlock. So go through a step by we are going to go through step by step, explain the we are going to look through the available, max, and need. These are the data type we have used. And we are going to see this. So first of all, we see the is that there are some data types. Some data types are used, which is available, max, allocation, and need. And in this, available is an integer data type, max is an array data type, allocation is also a array data type, and need is also array data type. So this part is for the data allocation, and we allocate the data, initialize the data. Okay. And request is also process request resources. Now we will check in this section that this section is for if the check request can be granted or not. We check the condition. Okay. From integer I to 2 for by applying the for loop. We apply for the loop. If check if request at this position is equals to need and request at this position is available. Okay. If so it happens, then do this. If it is not happen, then request just print the request denied process is not in the safe state and return 1. Now we are going to the continuation of the code from here that we seen that check for safety. Now it is checking for the safety, simplified check. If need is need zero, need index zero is equals to zero, and need one index is equals to zero. Basically, the need is a array data type, and it's both index is zero, then request granted, system in a safe state. Else system is granted, but it is not in the safe state. So here we have given this, and we check this condition what is going to be print. It prints request is granted, system is not in a safe state. Okay, so let's continue our topic. Now the second topic is write a C program for resource allocation graph, detect deadlock in a system. Okay, now detecting deadlock in a system using a resource allocation graph is typically involves the analyzing the graph to identify cycles. Why we are going to analyze the graph to identify the cycles. Okay. In wait for graph processes are represented and nodes. Okay. In wait for graph, this is a special type of graph. In this graph, प्रोसेस को हम नोट्स की तरह दिखाते हैं इन द हिंदी आई मीन टू से दैट processes are represented as nodes and resource instances are represented as its. Okay, now this is now we continue to the C program for this. Now here also we define the num resources, num process 3 and num resource 3, and here also data sorry array is defined as num process is a special array. There are two indexes, num process, num resources. Max demand also contains the one index is num process and num resources, and available contains one index num resources. So there are three array type data is used. One is allocation, one is allocation, second one is allocation, second is max demand, third is available. In allocation, num process is first index, sorry, zero index at zero index, and num resource at one first index. And similarly, in the max demand, and first zero index is num process, and first index is num resources, and in available is num resources. So Boolean is used for true and false. We use Boolean for returning the true and false. We all know that. We applying the for loop. Now the for loop is applied, and there is nested for loop. There is some nested for loop is also applied. We check that num processes. If it checks I is going for the num process, the Boolean can allocate is equals to false. If Boolean can allocate this is deadlock is equals to false, and if for the int j is equal to num resources, if this process, sorry, if this condition is true, then you return the true, and after that you break this. Sorry for this. You break this. You break this. Now continue to our code. If percentage can if it cannot allocate return to deadlock detected, this is the condition, this is the best condition, main condition for this. If it cannot allocate, we make the can allocate, and if it cannot allocate, return deadlock detected, and else return false, no deadlock. This means there is the some meaning that, in the comments I will mention that. Now in the main function, what we have done, we have initialized the allocation, max demand, and available matrices. Okay. If deadlock, print f. If it is deadlock, then print deadlock detected. If it is not, no deadlock detected, and return 0. So we continue to our next topic, which is write a C program to avoid deadlock using safety algorithm for single instance. Assume there are 4 resources and 16 resource types. There are 4 processes, sorry, and 16 resource types. Resource allocation tables are given below. Process 0, process 1, process 2, process 3. And maximum needs is also given 9, 4, 9, 6. Current need is 5, 3, 1, 2. We see the code of this also, and we understand this what it is exactly means. So in the main function, we define this. In the code, we firstly define the max. You are seeing this. We are defining the max. Allocation, which is also array data type, and there are some elements also, and available and finished. There are all of the array data types. So you understand the data types. Now in the main, we use the logic. What is basically logic in the main function? For we use the for loop. We use the for loop for this, And if it is not is a finish, it can allocate is equals to 0 and forward and check this condition, and can allocate is equals to 0 and break. There we use a boolean in the next question. Here we use can allocate is equals to 0, 1 or 0. Okay. And we continue to this in this also we choose check the can allocate for loop here we use, and after that we continue to this side. This side basically in P till N, and if finish P, if finish P is not equal to finish P means that it is not finished. It means it is not finished. It means it is not finished. It not finished. This simply means this is the main condition that we are seeing here. It is not finished. So what does the system? The system is not in safe state. Deadlock detected. Okay. Because of basically the deadlock, we see in the deadlock some process not going to be finished. So we detect that okay, this process not finished, and we have to print that system is not in safe and deadlock detected and return one. Else system in safe state and return 0. You can add here system is process is finished. You can add in the comment, but here is not use of that. So these are the explanation of the topics and code. And in the code section, we understand the basics, what we use and how it is used. So let's in this presentation.